We are going to discuss few set methods related to difference, intersection, and symmetric difference with update functionality. So first of all, on this slide, we'll discuss difference underscore update and intersection underscore update. We have already discussed the difference method and the intersection method. We will see what is difference underscore update, how it is different from normal difference, and we'll see what is the meaning of intersection underscore update, how it is different from normal intersection method. Now look at this first code. We have declared two set objects, S1 and S2. S1 has all the elements between 0 to 11, and S2 has the elements 1, 3, 5, 7, 9, 11, 13, all odd numbers. So if I print S1, S2, it will print S1, S2 on the screen. Now, what is the difference method? We have already discussed. So just to see the output, if I say S1 dot difference S2, that means I'm trying to calculate S1 minus S2. So it will print S1 minus S2 on the screen. You can look at this output. Now you can know what is S1 minus S2. So I'm trying to subtract S2 from S1. So 1 will be discarded, 3, 5, 7, 9, 11. All will be discarded. So what remains is all the even numbers 0, 2, 4, 6, 8, 10 in the S1. That is my result. But after implementing S1 dot difference S2, if I again print S1 and S2, S1 remains as it is, S2 remains as it is. So when I say S1 dot difference into bracket S2, it is trying to subtract elements of S2 from S1, and it is creating a new set as a result. It is creating a new set as a result. It is not making any changes to S1 and S2. Now that is the difference in case of update method. If I say S1 dot difference underscore update into bracket S2, it is doing the same thing. It is trying to subtract all the elements of S2 from S1. That means it is trying to calculate S1 minus S2. But when I say difference underscore update, that means whatever is the result will be stored in S1 itself. The set object using which I am calling the difference underscore update method, the result will be stored in S1. So in case of S1 dot difference and into bracket S2, it is doing S1 minus S2, but it is not changing S1 and S2. It is creating a different set as the output. But in case of S1 dot difference underscore update into bracket S2, it is also calculating S1 minus S2, but now the result will be stored in the calling object, which is S1 in this case. So after S1 dot difference underscore update into bracket S2, if I try to print S1 and S2, you can look at the output. Now S1 has changed. And what is S1? S1 is the result of S1 minus S2, which is 0, 2, 4, 6, 8, 10. S2 has been passed as an argument to this function or to this method. So there is no change in the S2. S2 will remain as it is. The calling object will change and will store the result. Whenever I use underscore update, the calling object will store the result of the method. That's why S1 has been changed. If you print S1 and S2, S2 will remain as it is. Similar to that, if you look at the second code, in case of intersection underscore update, these are my two set objects, S1 and S2 with values. S1 has all the values between 0 to 9, and S2 has values 1, 3, 5, 7, 9, 10. In normal case, if I say S1 dot intersection S2, that means I'm trying to find common elements between S1 and S2. And what S1 dot intersection S2 will do, it will create a new set of the result, and that will be printed. So what is S1 dot intersection into bracket S2? Common elements are 1, 3, 5, 7, and 9. Only 5 elements, 1, 3, 5, 7, 9. 10 is not common, remaining elements are discarded. So if I print the S1 dot intersection into bracket S2, it will print 1, 3, 5, 7, 9 on the screen, which is the result. But after implementing intersection method, if I print S1 and S2, S1 is not changed, S2 is not changed. That means this intersection method will find the common elements between S1 and S2 and will create a new set of the result without changing S1 and S2. But if I use intersection underscore update, so S1 dot intersection underscore update into bracket S2. It is also trying to find common elements between S1 and S2. But now the result will be stored in the calling object, which is S1 in this case. So S1 will store the result. So S1 will change. No change will happen in S2, but S1 will change. So after this S1 dot intersection underscore update S2 method call, if I again print S1 and S2 on the screen, my S1 has changed. From these elements, now S1 contains 13579, which is the result of intersection method. There is no change into S2. So you have to remember this. If you want to store the result into the calling object, use underscore update method, be it difference, be it intersection. Now we also have update method for symmetric difference. So the concept is same. We know what is the meaning of symmetric difference. It is the result of all the elements from both the sets, excluding common elements. That is the meaning of symmetric difference. So S1 dot symmetric underscore difference into bracket S2. If these are my two sets, and if I call symmetric difference, what it will do? It will execute symmetric difference on these two sets, S1 and S2. So 1 is common, discarded. 3 is common, discarded. 5 is common, discarded. 7 is common, discarded. So from S2, 9, 11, and 13 will be there. And from S1, 2, 4, and 6 will be there. So the result will have 6 elements, 2, 4, 6, and 9, 11, 13. So if you look at the output, it will be the same, 2, 4, 6, 9, 11, 13. So that is what symmetric difference is doing. So after implementing symmetric difference, if I again print S1 and S2, S1 and S2 are same. They have not changed. S1 is same, 1 to 7, and S2 is 1, 3, 5, 7, 9, 11, 13. That means whenever I call symmetric underscore difference, it will calculate symmetric difference between S1 and S2 and will store the result into another set object. And that is the only difference when you call underscore update. Symmetric underscore difference underscore update S1 dot, and if you pass on S2 as an argument, what it will do, it will calculate symmetric difference, but it will store the result in the calling object, that is S1. So the output of symmetric difference will be stored into S1. So after calling symmetric difference underscore update, if you print S1, S2 again on the screen, you can see now S1 has changed. And what is S1? S1 is the result of symmetric difference, 2, 4, 6, 9, 11, 13. No change into S2. S2 will remain same, but S1 will be changed because S1 is the calling object. So as we have discussed, always use underscore update method if you want to store the result into the calling object.